Here's question number 82. So again, we want to do partial fraction decomposition. So it states that 2x plus 9 all divided by 25x squared plus 20x plus 4. And so here we have a quadratic function, right? In the previous lesson it was a cubic function and we weren't exactly sure how to factor it. Therefore we used P over Q and the rational zero theorem as well as synthetic division, right, to get our factors. Here we have this quadratic function over here. So we know that the product of two numbers that we're looking for must be 100, right? A times C, and then the sum must be 20, right? And so those two numbers that have a product of 100 and a sum of 20 are obviously 10 and 10, right? So we can then write this as 25x squared plus 10x plus 4 is equal to 0. So we know that 5x is common here, right? So we have 5x within the parentheses plus 2, right, plus 2 times 5x plus 2 is equal to 0, while we have 5x plus 2 square is equal to 0. So we know this is what we have here, right? When we factored out the denominator, we have 5x plus 2 square. So we can write this as 20x plus 9 all divided by 5x plus 2 squared, right? And so again, when we're looking at this, this one's an easier problem because we have repeated linear factors here, so we can write this as a divided by 5x plus 2 plus b divided by 5x plus 2 squared, right? That is equal to 20x plus 9 divided by the denominator value, right? But what we can do is we can obviously get that common denominator, right? Which in this case is 5x plus 2 square. So we can say that 5x plus 2 square, right? Well, that must equal, that must be a times 5x plus 2, right? And then just plus b. So this over here must equal this over here, right? And the fact that the denominator values become equal, right? 5x plus 2 squared is the same thing as this 25x squared plus 20x plus 4. We can then just say that a times that 5x plus 2 plus b must equal 20x plus 9. So we have this over here. Now, again, the thing I would do here is, again, to just eliminate a, right? I could say that let x be equal to negative 2 over 5, right? Because obviously if x is equal to negative 2 over 5, then this expression over here does become 0. So we know that b is equal to, well, negative 2/5 times 20, right? So that gives us, well, that's just saying that's negative 8, right? So we have negative 8 plus 9, right? So we know that the value of b must be positive 1. So we know b is positive 1. Now we can say that let x be equal to 0, right? And so if x is equal to 0, right, we are again looking at this expression. So in that case, this would be 2a, right? 2a plus 1 is equal to 9. Right, we have this this equation over here, and all I did was really just put 0 in for x into this equation over here. And so solving this for a, we get 2a is equal to 8, and a it must be equal to 4. So we know that b is equal to 1 and a is equal to 4. And so we have these, we know what these two variables are, right? We know a is 4 and we know b is 1. Well, our original expression here was a divided by 5x plus 2 plus the b divided by 5x plus 2 squared, right? So when we write our final answer, we're just gonna put 4 in for a, and then we're gonna put 1 in for b. So our final answer for question number 82 is 4 divided by 5x plus 2 plus 1 divided by 5x plus 2 squared. So this over here is our final answer for question number 82. So thanks for watching.